Hello, geometry students. This is a video for example 2 for geometry topic 4, lesson 6. Use common parts of triangles. Is angle EGD congruent to angle EFH? We have to go with the given information, and we probably need to prove two triangles are congruent. Then once we prove the two triangles are congruent, we can say corresponding parts of congruent triangles are congruent, and we can prove this. So it takes a little while. All right, let's see what we have first. Because we have the markings, right? We have the markings, and since FG equals itself, and DF is congruent to GH, then segment DG is congruent to segment FH by the segment addition postulate. What I would have liked them to have done was to identify what two triangles they're trying to prove are congruent. Angle EGD. EGD is this one right here. And because it's that angle right there that they're trying to prove is congruent to EFH, which is that angle there, that helps me identify that this triangle is one of the ones that I need to prove is congruent, and the other one that would make sense is that one. Those two need to be proven congruent. That's why they went with DG is congruent to FH. Okay, moving on. Since DE is congruent to HE, we know this big triangle is isosceles. Therefore, angle D is congruent to angle H. So we already have this segment, and we have this segment, and we just had this angle. So now we have a side angle side congruent to a side angle and a side. So we can say that they're congruent. Let's see, did they do that? Right here. That's why we can say triangle DEDG is congruent to triangle EHF. And then, once you prove the two triangles are congruent, then you can say corresponding parts are congruent. So that's how we can finally prove EGD is angle. EGD is congruent to angle EFH. All right, hope I didn't lose you there. Hope I helped out with their explanation. Now we're going to try one on our own. Are segment VW and segment ZY congruent? So let's look where those are. VW is this one over here. ZY is this one over here. We have this little angle and the whole angle are congruent to that little angle and that whole angle. So probably all those pieces come together at some point to play in trying to find two triangles being congruent. And it's usually not the smaller ones. Even though we could go with this angle here is congruent to this angle here because of their vertical angles. Then we would have two angles congruent to two angles. But we don't have any sides. We don't have any sides that are congruent. So we're going to need to use the overlapping side, ZV, a V, or VZ. All right, that's a lot of hints. I haven't asked you to take pause, but go ahead and pause and come back if you're ready to hear more. So since I'm going to use VZ, and then I can use this big angle, then I can use the side that they want me to have. That's what we're trying to prove this side is congruent to this side. So I'm kind of putting it all together. I have this overlapping side, I have this full angle, I have this side. So what else do I know? Coming down, I don't know the sides, it's the angles. I know this little angle here. But these two angles here, since I know the whole angle is congruent to this whole angle, and I know that piece is congruent to that piece, I can say this little angle here, XVZ, is congruent to angle XZV, and then I think I'll have enough pieces. I wish I could mark this up. I apologize for the 15th time during all these lessons. I have this angle here, eventually. I have this side, and then I have the whole angle. So I think from angle, side, angle postulate, I can prove the two triangles are congruent. Once I can prove the two triangles are congruent, I can then say YZ is congruent to VW because of these CPCTC. Maybe they did write all that down. Let's see. Oh, wow. Yes, they did. They use ASA like I did eventually. Theirs is written out much nicer than mine. Go ahead and click pause if you want to look that over, but I think it's similar to what I described. That is it. So let's see what they have for homework. Should be able to do 14, 17 through 20, 25, and 27. That's it for this video. Have a great day.